Hello, I'm Anna Mackay, and this video is titled Arithmetic Sequences. It's one of 3 videos and it's the beginning of the topic Sequences and Series. So, if we had a sequence of numbers there, think about the connection between them. 4, 7, 10, 13. They're increasing by how much? It's the same amount. So, increasing by 3 each time. Fairly easy to see. So, we have to try and head towards writing this with a formula for it's an arithmetic sequence. So think about the jump or the difference between each number. So you have one term and then the consecutive term after that. So we have 7 take 4, the difference is 3. The next 2 terms, 10 take 7, difference is 3. 13 take 10, difference is 3. So a common difference of 3. So to write this as a formula, we use this formula here. We'll explain it more in a little bit. That for the term, the nth term, it's 3 times by n add 1. We'll go on to explain this in a little bit more detail. And this, what we've got here, the n belongs to the z positive. So what that stands for is the set of integers. So z in mathematical terms refers to integers. The positive sign refers to the positive integers. So we're talking about terms here, the first term, the second term, the third term. We can't have the negative terms and we can't have fractional terms. Why z, you might ask? It comes from the German word Zahl or Zahlen, which starts spelled like this, Zahl, or it could be Zahlen, I believe. And that's the German word for number or integer, essentially. So that's where it comes from. That's why it's a Z. Okay, so the recursive formula here. So if we've got one term, the nth plus one term, so the one after that, is represented by the term that we had, and we add on 3. So that matches this sequence that we had up here. And we often define, well, we need to define the initial term, so the first term, and in this case it was 4, because that helps us work out what all the terms after that are. And again in the set, where n belongs to, that's what that symbol there means, belongs to the set of positive integers. Alright, so breaking this down a little bit more. These are the different terms. So 4 is the first term, hence t subscript 1. Second term, etc. Let's think about the connection between them. 4 plus what gives you 7? 4 plus 3. Now moving to the next one. 4, so that initial number 4, plus how many lots of 3? Well, I'm sure as you know, it's 2 lots. So 2 lots of 3 would give, I'll put that there, 2 lots of 3. So thinking that in this case it was a 2 and this was the third term. Think about the connection there. Next, to get to 13 we have 4 plus how many lots of 3? 3 lots. And think about, so it's 3 lots in comparison to this is the fourth term. Think back there, there's 2 lots and it was the third term. So to get us to the second term, we would have to take the first term and add on the difference, which we know is 3. To get to the third term, you take the first term and add on what? Have a think about that. We're adding on 2 lots of the difference. Fourth term, t plus how many lots of the difference? 3 lots of the difference. And remember, the difference is 3. Okay, so how to write this for any term? We've got 4 terms written out here, but what if I want to know the 100th term? Without sitting there having to work them all out, how could you work out that term? So here's our formula. Please write this down. So to find the nth term, you take the first term, that initial term, and you add on n take 1 times by the difference. So remember, that's how we were getting this 3 here. If that's our n is 3, if you subtract off 1, you were getting, sorry, If n was 4, the fourth term, subtract off 1 to get a 3, and it's 3 lots of the difference. So that's the general term for this sequence. Now here's one example. Just a pointer on this one. When we have to show it's arithmetic, we actually need to use the word verify. Well, they're sort of interchangeable to a point. And how do we go on to prove that? Prove that a sequence is arithmetic, as opposed to geometric, which is a topic we're coming to later. Use the formula of this. Now think about that 4 and that 7 in the previous term. We did the 7 take away the 4, and to get that difference of 3. So I'll write that there. 7 take away 4 gave us the difference of 3. Now, the difference must be a constant. That can't be changing to be arithmetic. It can't be a variable either. All right, so how to prove that this is an arithmetic sequence? So we have to look at one term and the term after it. So the nth plus 1 term. So having a think what that would be. What have we done here? Well, if this was the general form, where we saw that n, instead of an n, we're going to substitute in an n plus 1. So here, where we have an n, we put in n plus 1. You can expand the brackets just like normal algebra there. 10 times n plus 10. So we've got 10 plus 8, hence how we get to the positive 18. And now, remember that formula on a previous slide? This is the formula to define an arithmetic sequence. You look at 2 consecutive terms and you must get a difference that's a constant. So, the nth plus 1 term is this, 10n plus 18, and that's what we have written here. And then subtract off the tn term, which is what we were given in the beginning. Subtract that off. You must use brackets here, because otherwise you won't get it right, because when you expand that bracket, essentially we're subtracting off 10n and you must subtract off 8. So these 10n's cancel there and you have 18 subtract 8, which gives us 10. And because we've met the rules of the formula and have a difference that's a constant, that therefore means, as it says here, that 10 is a constant. Something's happened with the slide here. We say the sequence is arithmetic. And so now we have proven that that particular sequence is arithmetic because it has a constant difference between the terms, between consecutive terms. Okay, that's the end of this video. Make sure you subscribe to the channel, give it a thumbs up, and the next video in this sequence is part 2 of arithmetic sequences. Thank you.